Namaste students. Today we will discuss about effect of change of pressure, which is given in page number 8 of NCERT book. Yesterday we had discussed about effect of change of temperature, and due to change of temperature solid change into liquid and liquid change into gas, and during change of a state of matter from one state to another state, the hidden heat, and for hidden heat we use the term latent heat, and it is of two types: latent heat of fusion and latent heat of vaporization. So increasing temperature and keeping constant atmospheric pressure, we can change solid to liquid, liquid to gas. But in the interconversion of states of matter, we had also known that some solids directly convert into gaseous state without going in liquid state, and for this process we use the term sublimation, which was discussed in interconversion of states of matter. And after solids, after heating, convert into gaseous state, and cooling convert into solid state, and this process is also known as sublimation. In this process, question arises, why some solids convert into gaseous state without going in liquid state? So answer of this question depends upon effect of change of pressure. Students, we know that when temperature increases, means when temperature increases, that means the particles of matter are far apart. When temperature increases, that means the particles of matter far apart, and due to large intermolecular space, the state of a matter changes from one state to another state. While when pressure increases, that means the particles of matter come close to each other. That means when we increase pressure, the particles of matter come close to each other, and this will be effective when the particles of matter have large intermolecular space, and applying pressure we can change the state of matter. Just for example, in gaseous state, we applying pressure, we can convert this gaseous state into liquid state and liquid state to solid state. That means having large intermolecular space, by increasing pressure we can change the state of matter. But one thing is important here: effect of change of temperature and effect of change of pressure both have behaves as opposite manner, because when increasing temperature the particles of matter are far apart, and when pressure increases that means the particles of matter come close to each other. So students, when we have to liquefy a gas, that means gas to liquid, and in the interconversion of states of matter we know that the process in which gas change into liquid, this process is known as condensation. But interconversion of states of matter we have not deals about under what condition this gas change into liquid. So here we will discuss about why gases change into liquid. Students, by increasing pressure and decreasing temperature we can liquefy a gas, because increasing pressure, that means the particles of matter come close to each other, and decreasing temperature also support the increasing pressure, because when we increase pressure that means the particles of matter come close to each other, and same way when we increase temperature that means the particles of matter move far apart. That means the liquefaction of gas is not possible. So it is when possible then increasing pressure and decreasing temperature. So here for condensation process we have to increasing pressure and decreasing temperature. So one thing is important for us: a particular pressure and a particular temperature is needed for liquefaction of gases, and for understanding we use the term critical temperature. Critical temperature, it is represented by Tc, and that temperature on which gases change into liquid or solid is known as its critical temperature. For carbon dioxide, for CO2, critical temperature is 30.98 degrees Celsius, because we know that CO2 is a gas, and when we increasing pressure and decreasing temperature, this CO2 gaseous carbon dioxide convert into solid carbon dioxide, and for this CO2, Tc critical temperature is 30.98 degrees Celsius. And for critical temperature, the pressure required for conversion of gas into liquid or solid is known as its critical pressure. Critical pressure Pc. Critical pressure represented by Pc. So at critical temperature, the pressure needed to gas to liquid or solid is known as critical pressure. And for carbon dioxide, Pc is 73.9 atm. 73.9 atm. And one term critical volume. At critical temperature and critical pressure, the space occupied by a gas is known as its critical volume, and it is represented by Vc, V suffix C. So when liquefaction of a gas, we have to need critical temperature, that is decreasing temperature, critical pressure, increasing pressure, and critical volume. That means at critical temperature and critical pressure, the space occupied by a gas is known as critical volume. So students, here we see that critical pressure for carbon dioxide PC 73.9 atm, while in critical temperature is 30.98 degree Celsius. We know that at 1 atm pressure CO2 is gas, and increasing temperature, that is 73.9, that means 74, approx 74 atm. So 74 times more atmospheric pressure than normal atmospheric pressure, this gas convert into solid form, and that's why it is an example of sublimation. But when this pressure reduces, that is in natural form, it directly convert, because their pressure is much large in comparison to the normal atmospheric pressure. That's why this gas in the form of solid directly convert into gaseous state without going in liquid state. That's why we use new term sublimation, because their pressure is much large. Therefore sublimation occurs. So students, we have discussed about effect of change of pressure, and effect of change of pressure mainly responsible for condensation, solidification, especially liquefaction of a gas, because without increasing pressure we cannot liquefy a gas into liquid or solid. So students, prepare notes and understand the taught topics, and homework: solve in text problems, page number 9, and question 3 and 4. 1 and 2 question of this part we had already discussed. So try to solve question 3 and 4 of page number 9. That's all. Thank you.